together. Harder now. Hold fast the sheets before she tears.
What if I told you that everything you believed about ancient travel is not true? Ancient sailors ventured out into the open ocean in vessels that modern engineers would consider fragile toys. They had no satellite maps, gyroscopes, or metal hulls, yet they managed to cross the Mediterranean Sea in the midst of stormy seasons. Roman captains relied on construction secrets and intuition that seem almost magical to us today. Watch the video to the end to find out how ancient designers conquered the elements without a single gram of modern electronics. First, let me tell you a secret that changes everything, because the strength of the Roman fleet did not lie in the thickness of the planks. Unlike medieval craftsmen, the Romans used an incredibly labor-intensive technique of mortise and tenon joints. Each plank of the hull was connected to the next by thousands of wooden dowels that were inserted into special grooves. This created the effect of a single monolithic shell that did not fall apart even under the strong impact of waves. This design allowed the hull to be both rigid and capable of withstanding enormous water pressure. This method required hundreds of thousands of man-hours and precision work from experienced carpenters. Imagine a huge ship where every detail is fitted together with millimeter precision. The spikes inside the grooves were fixed with wooden dowels, which prevented any displacement of the boards relative to each other. When the wood got wet, it expanded, and the joints became even more watertight and durable. It was this internal structure that allowed Roman ships to remain intact during storms lasting several days. Without such detailed workmanship, seafaring in those days would have been nothing short of collective suicide. Many modern researchers are amazed at how effectively this technology distributed the load throughout the hull. The ship was transformed into a flexible but incredibly strong network that dampened the destructive energy of the stormy sea. It was true engineering magic, hidden under a layer of protective resin and paint. The Romans built their ships as if they were a single piece of sturdy oak or pine. The wood was selected very carefully, taking into account the direction of the grain for each specific part of the vessel. Carpenters worked for years to create the perfect hull, capable of withstanding the pressure of deep water. Each joint was tested for strength before the ship was launched for testing. Errors in calculations could lead to disaster on the first serious voyage on the open sea. The Roman Empire invested enormous resources in the development of its shipyards along the coast. The technology of mortise and tenon joints allowed them to build ships much larger than those of their neighbors. This gave them an advantage not only in trade, but also in survival during natural disasters. Even if one part of the hull was damaged, the overall structure retained its shape and buoyancy. The rigidity of the structure was complemented by internal stiffeners, which were attached to the planking with particular care. Craftsmen used special tools to cut grooves to ensure maximum tightness of the wood joints. No glue could replace the mechanical strength provided by these hidden wooden locks. Each ship was the result of the work of an entire generation of engineers and ordinary shipyard workers. Roman architecture and shipbuilding was hundreds of years ahead of its time. It is important to understand that without these joints, the ships would simply fall apart under the weight of their cargo. Water constantly presses against the sides, trying to find the slightest crack or weak spot in the structure. The Romans eliminated such places by repeatedly duplicating fasteners across the entire surface. It was the most expensive and complex construction technology of all those existing in the ancient world. History has preserved evidence of ships that served for decades in the harshest conditions. They returned to port after hurricanes with only superficial damage to the deck or sails. The main hull remained intact thanks to the very secret of invisible spikes inside the planking. This legacy of antiquity is still being studied by wooden shipbuilding experts around the world. We would love to hear your thoughts on this. What do you think about this painstaking construction technique that does not use metal bolts? Write about it in the comments and be sure to subscribe to the channel so you don't miss any new discoveries. Your feedback helps us make our content even more detailed and high quality for all viewers. Want to know the main secret of the warriors of the sea, hidden below the waterline of Roman ships? In addition to storms, sailors had another dangerous enemy, sea worms that destroyed wood from the inside. To prevent the ship from losing its strength, the Romans came up with the idea of wrapping the underwater part of the hull with thin sheets of lead. This lead armor was attached to a layer of resin-soaked fabric or natural wool. This protection made the hull virtually impervious to biological destruction for decades of service. The lead not only protected the wood, but also served as additional ballast, increasing the overall stability of the ship. The heavy lower part helped the ship return to an upright position more quickly after a strong sideways roll. This was critically important when huge waves tried to capsize the ship in the open sea. The lead sheets were soft and fit snugly around all the curves of the wooden hull. The smooth bottom reduced water resistance, allowing the ship to develop greater speed in the wind. Roman engineers understood that the cleanliness and integrity of the hull directly affected the crew's chances of survival. Without this lead protection, the wood would have rotted in a few years, turning the ship into a death trap. Each sheet of lead was carefully checked for defects before being finally installed on board. Copper nails with special wide heads created an additional protective layer that did not rust. Sailors knew that their lives depended on the quality of the carpenter's work in the dry dock. The ship became a veritable fortress, capable of withstanding both salt water and the passage of time. Lead was an expensive material, but its use paid off in the long term. Roman trade required reliable ships capable of transporting valuable cargo over long distances. Protected ships could remain in the water for years without the need for frequent and expensive repairs. This allowed the empire to expand its borders and maintain stable communication between the provinces and the capital. The thickness of the lead sheets was selected to provide protection without overloading the ship. Craftsmen nailed the sheets overlapping so that water could not penetrate the protective layer of armor. Copper and lead created a galvanic couple, which further prevented the growth of unwanted marine organisms. This was one of the first applications of a scientific approach to material protection in history. Marine archaeologists often find remnants of such plating on sunken ships from the Roman period. This proves the widespread use of this technology on large merchant and military ships of the empire. The lead sheathing was so effective that the wood underneath it was often preserved in perfect condition. Even after 2,000 years, we can study the details of the construction thanks to this protection. Lead armor was standard for all ships embarking on long and dangerous expeditions. It gave the captain confidence that the hull would not leak in the midst of a storm. Every ton of lead contributed to the overall safety and success of the fleet's voyage. The Romans spared no expense on metal to preserve their priceless merchant and military ships. It is interesting to see how you perceive this topic in the context of modern ship protection technologies. Do you consider such a solution rational for the level of scientific and technical development at that time? Tell us in the comments if you knew about the existence of metal plating on ancient ships. Your opinion is valuable for the development of our historical channel in discussion of topics. But even the strongest hull is useless if the ship cannot be effectively controlled in the fury of the elements. Guess what happened next when the Romans faced the problem of controlling giant heavy ships? In the next chapter, you will learn how they created a steering system that was centuries ahead of its time. Get ready for a story about double rudders and the skill of ancient helmsmen. You've definitely never heard about this unique steering secret in detail before. Unlike modern ships with a single rudder, Roman ships were equipped with two powerful steering oars. They were located on both sides of the stern and were controlled synchronously through a system of levers. This gave the captain incredible maneuverability and the ability to stay on course in crosswinds. If one oar was damaged during a storm, the second allowed the ship to continue moving and maintain control. The dual steering system was an insurance policy that saved thousands of lives in critical maritime situations. The steering oars were huge and required extraordinary physical strength and skill from the sailors. Special leather cuffs protected the holes in the hull from water ingress, keeping the hold dry. The captain could change the depth of each oar depending on the sea and wind conditions. This allowed for fine-tuning the balance of the ship, preventing dangerous rocking that could lead to capsizing. Such a system was much more effective for that time than a central rudder at the stern. The Romans perfected the design of these oars, making them the main tools for survival in a storm. Thanks to this design, Roman merchant ships could enter narrow harbors and maneuver among rocks. During storms, helmsmen could work in pairs, leaning on the levers with all their weight to turn the ship. The ability to cut the waves at the right angle was the only way to prevent the sea from breaking the deck. Every movement of the rudder oar was calibrated by years of practice and passed down as sacred knowledge. The double rudders provided redundancy, which is extremely important for any vehicle in an extreme environment. When a wave hit one side, the helmsman on the other side could compensate for the impact. This created a stabilizing effect that was not available to ships with the primitive single steering systems of the period. The steering levers were often connected by a crossbar to synchronize the movements of both oars simultaneously. The material for the steering oars was selected from the strongest types of wood capable of withstanding enormous pressure. The shape of the oar blade resembled a wing, which improved hydrodynamic characteristics and made it easier to steer the ship. The Romans understood the importance of leverage and used it to multiply human effort at the helm. This allowed a few people to control huge ships weighing hundreds of tons. During battles, the maneuverability provided by two rudders allowed the Romans to quickly turn for ramming. In peacetime, this helped to avoid shoals and the dangers of coastal navigation in fog. The oar mounting design was so reliable that it could withstand many days of stress without showing signs of wear. Each ship had spare sets of rudder oars in a special compartment in case of an accident. Helmsmen on Roman ships were considered the elite among sailors and received higher wages for their work. Their skills were honed in endless voyages across all the seas and oceans known at the time. They had to feel the ship as an extension of their own bodies, reacting to the slightest changes in the waves. Without their art of double steering, even the most durable ship would have been doomed. Like this video if you are impressed by this ancient technology of maneuvering on the open sea. We encourage you to subscribe to our channel so you don't miss new topics about the great engineers of the past. Your support helps us find the rarest facts about Roman history and culture. Write in the comments how difficult you think it was to control such a system alone. In the next chapter, we will discuss how sails helped the Romans not only to move, but also to survive. Did you know that rigging could be as flexible as human muscles? We will reveal the secrets of ancient sails that allowed ships to battle hurricanes and emerge victorious. It will be a fascinating story about fabric, ropes, and the power of the wind. What I am about to show you will change your perception of the power of wind and sails. The Romans used huge square sails, but their secret lay in a complex system of ropes and reefs. They could quickly reduce the sail area by simply pulling it up to the yard in a matter of seconds. This allowed them to react instantly to sudden gusts of wind, preventing the mast from tilting critically. The fabric of the sails was often reinforced with leather inserts in areas of greatest stress to prevent tearing. All rigging was designed to be serviceable in the most severe conditions. The ropes were made of high-quality flax or hemp and impregnated with special compounds to protect them from salt. Roman sailors knew how to use additional sails at the bow to stabilize the ship's course. This allowed them to keep the bow of the ship strictly into the wind, which was vital for safety. Blocks and pulleys made of durable wood and bronze greatly facilitated the work with the rigging. The system was so well thought out that even a small crew could handle the rigging. The Romans used different types of sails for different weather conditions and strong wind directions. Sails often had bright colors or emblems so that the ship could be seen from a distance in foggy conditions. The complex knots invented by ancient sailors are still used in modern sailing. The flexibility of the rigging allowed the entire structure to breathe with the gusts of wind, absorbing excess load. The masts were held in place by numerous stays, which distributed the pressure of the sails evenly across the entire hull of the ship. In the event of a sudden storm, sailors would climb the yards to secure the sails as securely as possible. This work required tremendous courage and dexterity in strong winds and rain. The Romans developed a system of signals to coordinate the crew's actions while working with the rigging. Each rope had its own name and purpose, which sailors knew by heart from childhood. The quality of the sailcloth determined the speed and maneuverability of the ship in the empire's trade in military expeditions. The fabric had to be both light and dense enough to keep the wind out. Entire workshops were dedicated to sewing and repairing sails for the state fleet in ports. Engineers calculated the sail area based on the displacement and hull shape of a specific type of ship. The Romans also experimented with triangular sails on small vessels for better upwind performance. However, for large merchant ships, the square sail remained the mainstay because of its enormous pulling power. Proper rigging allowed for long voyages across the open sea without stopping at ports. This was the key to Rome's dominance of all Mediterranean sea routes. During a storm, sails could be both a salvation and a cause of a ship's demise. The ability to drop the wind in time was the main skill of an experienced boatswain on board a ship. The Romans used special shock-absorbing inserts in the ropes to soften sudden jerks during storms. The rigging was a complex web where each thread had its own important functional significance. The ropes were regularly treated with tar and special organic oils to protect them from rotting. Sailors constantly checked the rigging for fraying, which could lead to breakage in battle. The reliability of the rigging was a source of pride for Roman shipbuilders and a guarantee of the safety of trade routes. Without this complex system of sailing equipment, the ancient world would never have become so global. Do you think modern sailors could figure out such a large number of ropes without instructions? In the next chapter, you will learn how they coped with this terrible weather using the secrets of ballast. How could ordinary stones in the hold save a huge ship from inevitable capsizing at sea? It is basic physics that save the lives of thousands of people every year. The internal structure of the Roman hold was designed with the strict laws of physics and ancient hydrodynamics in mind. To ensure the stability of the ship, the Romans used heavy ballast consisting of river stones and sand. It was placed at the very bottom, lowering the ship's center of gravity as close to its keel as possible. This made the ship resistant to capsizing even when it was tilted sideways by waves. The correct distribution of weight in the hold was a science in itself, which the captain personally checked before departure. Without sufficient ballast, a tall merchant ship would become a light splinter on the surface of the water. Often, the cargo itself served as ballast, for example, thousands of heavy amphorae filled with wine. The amphorae had sharp bottoms that dug securely into the layer of sand at the bottom of the hold. This prevented them from moving during heavy swells, which was critical for balance. If the heavy cargo began to move freely inside the ship, it would inevitably lead to disaster. The Romans created multi-layered structures of goods and filler to create a monolithic mass inside the hull. This allowed the ship to roll smoothly on the waves, keeping the mast and rigging upright. Careful stowage of the hold ensured that the ship could withstand even the most prolonged storm. In addition to stones, metal ingots or heavy building materials were sometimes used as ballast. This allowed the ship's draft to be adjusted, depending on specific sailing conditions and cargo weight. Captains kept special logs where they recorded the ballast placement scheme for each individual voyage. The layer of sand at the bottom also acted as a filter for the bilge water that collected at the bottom. This made the pumps work easier and kept the mechanisms from getting clogged up with small splinters or debris. The sand absorbed excess moisture and helped maintain the desired microclimate inside the ship's cargo compartments. The Romans understood that even small details could affect the overall survivability of a ship on the open sea. When unloading goods ashore, ballast often had to be replaced with other heavy objects. The ship never went to sea empty without sufficient weight in the lower part of the hull. This was an iron rule of ancient navigation, the violation of which was punishable by law and public censure. There were special port services that monitored the correct loading of ballast on state ships. Interestingly, the Romans sometimes used seawater as temporary ballast in special containers. However, stones and sand remained more reliable due to their stability and lack of flow. Properly laid ballast served as additional reinforcement for the keel and lower ribs of the hull. This created a solid foundation on which the rest of the deck and superstructure construction rested. Experienced sailors could determine whether the ballast was laid correctly by the ship's behavior on the waves. If the ship returned from a list too sharply, it meant there was excess weight at the very bottom. A too slow return indicated insufficient stability and the danger of capsizing in the next wave. The captain had to find the perfect balance between speed and the safety of the ship's stability. In an emergency, ballast could be partially thrown overboard to lighten the ship. However, this was only done in the most extreme cases, when the ship was in danger of running aground or being completely destroyed. More often, on the contrary, attempts were made to secure the ballast even more firmly with wooden partitions and struts. The stability of the cargo was equivalent to the stability of the entire crew's lives in the raging sea. Roman engineers calculated the volume of the hold so that the ballast occupied a strictly defined space. This allowed for the most efficient use of space for transporting goods without compromising navigation safety. The harmony between commercial profit and the requirements of physics made the Roman merchant fleet the most successful. Ballast was the invisible hero of every successful voyage from Alexandria to the port of Ostia. What you never saw in the movies was the true role of the Roman forecaster on board. Experienced captains possessed knowledge of the weather that was passed down through the generations and kept secret. They could predict the approach of a storm by the color of the sunset or the behavior of dolphins many hours in advance. This gave them precious time to prepare the ship, to lower the sails and batten down the hatches. Intuition and experience replaced modern barometers and complex satellite images of cloud cover in the sky. Sailors read the sea like an open book, understanding every change in the current or the shape of the waves. They knew at what time of year the winds blew steadily and when the sea became unpredictable. Knowledge of the stars allowed them to find their way home, even when the coast was hidden behind a veil of rain. The Romans created detailed maps of currents and winds, which were recorded in special books called periplus. This was a database of information about the behavior of the elements in every corner of the Mediterranean, accumulated over centuries. In the next chapter, you will learn how they coped with the weather using only physical strength. Guess how long it took to prepare a ship for a real hurricane at sea? Forecasters were able to determine the humidity of the air by the smell of salt and the direction of light breezes from the shore. They taught young sailors to notice subtle signs of impending changes in the atmosphere above the water. The collective experience of generations formed a reliable early warning system for the entire fleet. This made it possible to avoid accidental collisions with powerful cyclones in open waters. Each port had its own experts who advised captains before they set out on long voyages. These people knew the peculiarities of the local coastline and the treacherous underwater currents near rocky capes. Knowledge of the ebb and flow of the tides was also part of the mandatory skill set of an ancient navigator. They understood how the phases of the moon affected water levels and the strength of coastal storms. The Romans believed that the sea had its own character and that one had to know how to listen to and respect it. Rituals and offerings to the gods of the sea were part of maritime culture, but they were complemented by strict observations. Birdwatching helped to determine the proximity of land and the direction of prevailing air currents over the sea. All these techniques together created a unique system of survival in conditions of complete isolation. The captain on the bridge was not only the commander, but also the chief analyst of all natural data. His eyes constantly scanned the horizon for the slightest signs of weather changes or enemy movements. The speed of reaction to changes in the wind determined the success of the maneuver and the safety of the ship's masts and sails. It was a continuous work of the mind and senses throughout the entire voyage. Knowledge of local winds, such as the Mistral or Sirocco, allowed routes to be planned as efficiently and safely as possible. The Romans used favorable currents to speed up the delivery of cargo, saving time and energy for their crew. The voyages contained descriptions of all reliable bays where it was possible to wait out bad weather in complete safety. This information was a strategic resource for the state and was protected from foreign competitors and pirates. Knowledge was passed on through a system of personal mentoring and practical training on real ships at sea. Young men began their service as ordinary sailors, gradually absorbing the wisdom of their older comrades and experienced navigators. By the time they attained the rank of captain, they had become true experts in the meteorology and hydrography of their time. This ensured continuity and a high standard of navigation throughout the vast Roman Empire. In the next chapter, we will talk about masts that could bend but never break in a storm. Did you know that wood can be as flexible as steel if it is properly selected and processed? This will be a story about the tallest parts of a ship, which took the brunt of the elements. We will learn how the Romans prevented the destruction of masts during hurricane-force winds. The masts of Roman ships were made from solid coniferous tree trunks, which possessed natural and important flexibility. This was important because a rigid mast could simply break in strong gusts of wind. The wood was selected so that it could bend under enormous pressure and then return to its original shape. The base of the mast was attached to a powerful wooden block, the step, which distributed the load across the entire keel. The Romans used a system of thick cables to keep the structure balanced when rocking. During extreme storms, the mast could be partially lowered or even cut down in extreme cases. This was a rare measure, but it often saved the ship from capsizing in strong winds. The flexibility of the mast worked in tandem with the elasticity of the hull, creating a harmonious system for absorbing the blows of the elements. Mast makers were valued like gold, as the ship's survival depended on the wood. Every knot and fastening in this system was checked daily to eliminate the risk of sudden failure. Tree trunks for masts were kept in special conditions to achieve the required degree of strength and elasticity. The right choice of wood allowed the mast to withstand wind pressures several times greater than the design pressure. The stays, or shrouds, were made of materials with a specific tensile coefficient to dampen wind gusts. This prevented shock loads from being transmitted directly to the ship's hull, protecting it from cracking. The tension of the ropes was adjusted by experienced sailors depending on the wind strength and the current course of the ship. The mast became a living part of the ship's body, responding to every change in the external environment. Engineers calculated the height of the mast to ensure maximum speed without compromising overall stability. A mast that was too high created excessive leverage, which could capsize the ship in a sudden side gust. The balance between the power of the rigging and safety was the main criterion in the design of new ships. The Romans achieved perfection in this calculation, building some of the best ships of their time. The top of the mast was often equipped with special blocks for signal flags and observation posts for sailors on watch. The lookout on the mast was the first to see signs of land or an approaching storm on the distant horizon. His job was dangerous due to the strong swaying at height, even during minor waves. However, it was this position that gave the crew the advantage of time to make the right decisions. The mast was reinforced with additional beams to prevent the structure from being torn out under heavy pressure from above. The entire system was interconnected, from the tip of the mast to the deepest point on the keel of the ship. Roman carpenters used special wedges to secure the mast in the step, allowing for microscopic movements of the wood. This prevented fatigue failure of the materials during long ocean voyages. Ports had special cranes for installing and replacing masts on large merchant ships. This process required high precision and coordination between dozens of workers and experienced shipyard engineers. A high-quality mast could last for many years, enduring hundreds of storms and hurricanes on the open sea. The Romans created a system of standards for logging to provide the fleet with the best raw materials from distant provinces. Knowing how a mast behaved under load allowed the captain to safely use the sails in a storm. The flexibility of the wood served as an indicator of wind strength. The degree of bending determined the need to reef the sails. It was an intuitive and at the same time accurate system for controlling the load on the entire rigging. The mast remained a symbol of the power and reliability of Roman ships, striving for new horizons and discoveries. Ancient craftsmen knew that wood is a living material that requires constant care and attention. Masts were regularly impregnated with protective compounds to maintain elasticity and prevent drying out in the sun. This attention to detail and deep understanding of the properties of materials made Roman ships invulnerable. Each mast was the result of the labor of hundreds of people striving for the ideal in shipbuilding of their era. No ship was completely watertight, and dealing with water in the hold was a constant task. The Romans used advanced bailers and screw pumps to pump out excess water. This allowed the ship to stay afloat even with small leaks from wave impacts. The pumps were powered by the muscle power of sailors, who took turns in a continuous cycle. Keeping the hold dry was important not only for the preservation of cargo, but also for overall stability. Water at the bottom created a free surface that could cause the ship to capsize quickly when it tilted. Sailors knew that every minute the pump was idle brought them closer to death in the raging ocean. Therefore, discipline in pumping water was ironclad on every Roman ship at sea. The pumping systems were located at the deepest point of the hold, where all excess moisture from the cracks flowed. Some Roman ships were equipped with automatic bailers that operated from the movement of the ship itself on the waves. Roman engineering was focused on automating the most difficult and vital processes on board. It was a real battle between ancient technology and the primitive and formidable power of the world's oceans. The design of the pumps included leather valves and bronze cylinders, which ensured high durability and reliability of the mechanisms. Sailors underwent special training in the repair and maintenance of these devices directly on the open sea. The availability of spare parts for pumps was a mandatory requirement for every merchant ship of the empire. The captain checked the serviceability of the water pumping system before each departure from port. In the event of a large hole, the entire crew was mobilized to manually pump out water using buckets. It was exhausting work that required extreme exertion for many hours at a time without rest. The Romans built ships with double bottoms in some places for added safety in collisions. This allowed them to localize leaks and gain time for emergency repairs to the hull while still afloat. The efficiency of the pumps allowed the Romans to operate ships that other cultures would have considered unfit for service. This increased the service life of the fleet and reduced the cost of building new expensive ships every year. Water drainage technologies became the basis for the development of Roman hydraulic engineering, not only at sea but also on land. The experience of sailors was used in the design of urban sewage and water supply systems in large cities. Some pumps were driven by the rotation of large wheels on which sailors walked like in a squirrel wheel. This allowed them to use their body weight to pump huge volumes of water in a short period of time. Such mechanisms were the pinnacle of ancient mechanics and demonstrated a deep understanding of the principles of leverage and transmission. The Romans were not afraid of complexity if it gave them an advantage in the fight against the elements. Each ship had several independent pumping stations in case one of them was damaged in battle. Redundancy of systems was a key principle of Roman engineering in any area of national importance. Sailors felt safe knowing that the technology was capable of dealing with water entering the hold. The reliability of the pumps was confirmed by thousands of successful crossings through stormy areas of the world's oceans. The struggle for the ship's survivability was a collective task that united everyone from slave rowers to high-ranking captains. The common goal of survival erased social boundaries in moments of mortal danger aboard a sinking ship. Water pumping technologies were the invisible shield that protected Roman power at sea for centuries. We must remember these achievements as the foundation of modern marine engineering and safety. The bow of a Roman ship had a special shape designed to effectively cut through high and heavy waves. It was often decorated with massive decorative elements, which also served as additional weight to stabilize the entire vessel. The high side of the bow prevented large amounts of water from entering the deck in heavy seas. The Romans designed the decks with a slight slope so that water would quickly drain back through special openings. This was critical for maintaining buoyancy in conditions of continuous flooding during heavy storms. The design of the bow allowed the ship to glide smoothly over the crest of the wave rather than burying itself in it. This was achieved by precisely calculating the buoyancy of the front of the hull and correctly distributing all cargo. Captains carefully monitored the ship's trim to ensure that the bow was always in the correct position. The powerful beams holding the bow section together withstood direct blows from tons of salt water for many hours. Every element of the design reflected centuries of experience in conquering the watery desert and its caprices. The Roman ship was a perfectly balanced machine, where every detail worked toward a common goal. Reinforcing the bow was also important for protection against collisions with floating debris or other ships. The underwater part of the bow was often equipped with a ram on military ships, but merchant ships also had a reinforced stem. This gave the hull additional longitudinal rigidity, which was necessary when moving against strong headwaves. Craftsmen used the hardest woods to create the bow fittings, which were subject to the greatest stress. All the energy of the wave impact had to be effectively distributed throughout the ship's frame. The shape of the bow also affected aerodynamics and spray formation when sailing at high speed under full sail. The Romans sought to make their ships not only durable, but also aesthetically perfect in every line. The decorations on the bow often had symbolic meaning, invoking the protection of the gods and good luck on a dangerous journey. This combination of practicality and faith was a characteristic feature of all ancient maritime civilizations. The bow housed the anchoring devices, which required massive reinforcements of the deck and sides of the ship in this area. Roman anchors were heavy and reliable, capable of holding the ship close to shore even in strong winds. Lifting and lowering the anchor was a complex procedure that required the coordinated work of the entire bow crew. The strength of the bow bits ensured that the rope would not break when the ship jerked sharply on a wave. The deck in the bow was often raised to create additional volume and dry space for the crew. It could house officers' cabins or storage space for valuable cargo that was most sensitive to moisture. The high position of the bow also made it easier to observe the horizon and detect hazards in the ship's path. Every decision made by the engineers was dictated by the desire for maximum safety and comfort while sailing. Studying the shape of the bows of ancient ships helps us understand how the ancients coped with wave resistance. Modern computer models confirm the high efficiency of Roman hull shapes for the conditions of the Mediterranean Sea and the ocean. This knowledge formed the basis of classical shipbuilding, which developed in Europe in the following centuries. We still use the principles laid down by ancient craftsmen in the shipyards of Ostia and Carthage. The Roman ship's bow became a recognizable symbol of maritime power, depicted on coins and triumphal arches. It embodied man's ability to overcome any obstacles and move forward against the will of the elements and enemies. The strength of this design ensured that Rome would remain the master of the seas for many centuries of its existence. Each ship was the embodiment of imperial ambitions and the highest technical skill of the workers. Last but not least, strict discipline and high professionalism of the entire crew were essential for survival. Roman sailors underwent rigorous training where everyone knew their place and duties in case of trouble. During a storm, perfect order reigned on board, as any panic was tantamount to death. Commands were given clearly and carried out instantly, allowing the ship to react quickly. The ability to work as a team under tremendous pressure was the main quality of every Roman sailor on board. The captain enjoyed unquestionable authority, and his decisions were not discussed even in the most frightening moments of the storm. The sailors believed in their ships and in the profound knowledge of their commanders, which gave them the strength to fight. Faith in the gods who protected the sea also played an important role, creating psychological comfort in conditions of risk. The Roman maritime tradition was built on a combination of engineering calculations and the unyielding will of ordinary people. Every ship that survived a storm was a monument to this unique alliance of mind, technology, and human spirit. The history of Roman seafaring is a story of how knowledge makes a person stronger than any formidable force of nature. We conclude our story with the hope that these lessons from the past will be useful to you as well. Crew training began at an early age, when young men were taught hard work and maritime life in ports. Training included not only physical exercises, but also the basics of navigation, meteorology, and first aid for the wounded. The team's cohesion was tested in training maneuvers and real encounters with pirates on trade routes. Every crew member understood that a personal mistake could cost the lives of all his comrades. Discipline was maintained by strict rules and a system of rewards for courage and resourcefulness during voyages. There was a clear hierarchy on board, ensuring the smooth transmission of orders from the captain to the lowest sailor. Psychological resilience was trained through exposure to danger and long periods at sea. This created a caste of professional sailors for whom the sea was their second home. During storms, the captain personally remained on deck, inspiring the crew with his example of calmness and confidence in success. Trust between officers and sailors was the foundation on which the safety of the entire ship depended in critical moments. The Romans used special methods of psychological relief and relaxation to maintain high morale during long voyages. Quality food and care for the health of the crew were also priorities for ship owners. Knowing that they had the power of a great empire behind them gave sailors an extra incentive to do their duty to the end. Sailors' families often received state support, which ensured the peace of mind and loyalty of those who were on dangerous voyages. The social status of sailors in Rome was quite high, especially during periods of active maritime expansion by the state. This attracted the best people to the Navy, who were willing to take risks for the glory and wealth of their country. The culture of mutual assistance at sea required Roman ships to help any other ships of the empire that were in trouble. This created a unified safety net across all the seas controlled by Rome at that time. Common values and traditions united people of different nationalities under the single flag of the Roman fleet in the Mediterranean. Unity of spirit was no less important a weapon than the ballistas or reinforced bows of their warships. Roman maritime psychology became the basis for many modern codes of honor and rules of conduct at sea in emergency situations. We still admire the fortitude of the ancient navigators who fearlessly sailed into the unknown on their wooden ships. Their legacy is not only the wreckage at the bottom of the sea, but also a living tradition of courage, skill, and human dignity. Thank you for watching this detailed story about the great sailors of the past to the very end. Roman ships were true masterpieces of engineering for their time, combining strong joints with protective armor. They proved that even without modern navigation, it is possible to conquer the oceans by relying on a scientific approach and the experience of generations. Do you think modern people could survive in such conditions using only ancient wooden technologies? Please suggest topics for future videos that you would like to see on our channel in the near future in the comments. And don't forget to subscribe to our channel so you don't miss out on new interesting episodes about great history and technology. Your activity helps us grow and tell you about the most interesting things from the world of the past and present.